Hello everyone, and welcome to my video about underrated seawater. First things first, what is the ultimate goal of this video? Well, the goal of this video is to demonstrate to you, the viewer, just how easy it is to break down ocean water into two highly prized substances. One of these substances is salt, and the other is simple drinking water. Yep, that's right, drinking water. Both of these substances are essential to life on Earth and are therefore essential to human survival. There are many other valuable uses for ocean water as well, but to keep things simple for this video, I have decided to stick with salt that can be extracted from ocean water, as well as potable water that can be extracted from the ocean water as well. Now, water, as many of you would be well aware of, is the single most important ingredient for sustaining life. Not only for humans, but for all life forms on this planet we call Earth. Water is also, of course, the most important ingredient to sustaining plant life. Without water, plants die. Without plants, we have no food. This is simple. Some may say, now wait, without water, plants die, but other animals would continue to thrive. Wrong. Without water, everything dies. Plants die, cows die. Plants die, lions die. Plants die, we die. Without plants, herbivores, also known as plant eaters, die. Without plant eaters, carnivores, also known as meat eaters, die. Water is the key ingredient in the circle of life. I find water absolutely fascinating, and the reason for this fascination is very likely down to how I view water. Some time back, early in my schooling, I was taught all life on Earth may have originated in water. And if you were to trace the tree of life back far enough, you would find that all life evolved from fish and other sea critters. This led me to the simple conclusion that all life on land simply evolved enough to carry its water with it to survive. This was what allowed us to leave the water while other life forms remained in the ocean. In fact, humans alone consist of about 60% water. It is evident that we simply rose from the oceans billions of years ago and evolved to carry our water with us. When viewing this subject with this perspective, in many ways, we never really left the water. We are basically living water bags with some bones in it. How's that for a mind-altering perspective? Now for some interesting facts about water. First, Earth is the only planet in the solar system and the universe that we know of where water can exist in all three states. What are these three states, I hear you asking? Well, the first is as a gas. This gas is the clouds we see, the fog we drive through, and the fog from our breath when we breathe on a cold glass window pane. The second state is as a liquid. This is the water we see in the oceans and the rivers that run over the earth. It is also the rain that falls from the skies. And the third state is as a solid. This is the ice we see in the snow, the ice we see on frozen lakes, and the ice we collect from hailstorms. Ice is especially prevalent at the top of the earth and at the bottom of the earth. It is absolutely amazing that Earth can sustain water in all three states. Think of it like this. Mars is considered to be within or on the edge of the Goldilocks zone for planets. For those unsure of what the Goldilocks zone is, the Goldilocks zone is considered the zone that a planet can exist in and still have the possibility of supporting life. Planets outside this Goldilocks zone are very unlikely to be able to sustain life because conditions do not meet these Goldilocks prerequisites. That is, the conditions are not too hot and are not too cold. They are just right. And Earth is just that. In fact, Earth is refined even further than this. Allow me to explain. Although Mars is within the habitable zone, also known as the Goldilocks zone, life has not been found on Mars. This leads one to think that perhaps for life to exist, water must exist in all three states. Also, another interesting point is that the Moon is definitely within this Goldilocks zone. In fact, it is the closest celestial body to Earth and should, from everything we have been taught to believe about the Goldilocks zone theory, be the only other celestial body within the solar system that should support life. Yet, from the studies of the Moon to date, life has not been found there. In fact, water has not been found on the Moon in any other state other than frozen. So, as you can see from the information I have just provided you, the value of water on Earth is simply underrated to say the least, when in fact it should be considered to be the most valuable commodity, substance, or asset that all life on Earth has. So this one simple fact has led me to making this video. Water is simply undervalued. I believe that educating people on the importance of water is the most essential thing anyone can do to help support future generations of life on Earth. Without water, everything stops. To be honest, without water, and in ideal conditions, humans live 3 days. That's 72 hours. This also indicates that we as humans are always living 3 days from death. Another earth-shattering perspective you could have perhaps done without. Some more interesting facts about water. The ocean covers 71% of the Earth's surface. Technically, the Earth is a water world. There is a total of 1.3 billion trillion litres of water on Earth at the moment, and most of it cannot be drank by land animals. In fact, it is estimated that there is only 3% fresh water on Earth, while there is 97% ocean water available. It is also a fact that we are running out of fresh water. Every year, we inch closer and closer to what has been dubbed Day Zero. Having the skill of being able to harvest your own water and salt from the ocean is one of the most important skills anyone should learn. Okay, so if you want to go ahead and actually try and distill ocean water to retrieve drinkable water, so fresh water, as well as the salt content from the ocean water, you're going to need a couple of different things. The first thing, of course, is a bucket. You're going to need the ocean water, you're going to need a jug, and you're going to need an air still. That's how I'm going to go about doing it today. There are other primitive methods of doing it. You can use a copper in that as well, used for the distillation of alcohol. However, this here is the most efficient way that I have found so far. It doesn't require us to go lighten a fire, it doesn't require wood, and it runs off very little energy as well. This one here in particular runs off 340 watts of power, which is very tiny in comparison to, say, a kettle, which will flash boil water, but it will flash boil it at 2,200 watts of power. So it's very heavy. In Australia, it's about 30 cents a kilowatt at the moment, a little less than that perhaps. So you're talking 60 cents an hour to run a kettle, whereas this is next to nothing. In fact, this is small enough to run off a 600 watt inverter back to a set of batteries. So providing you've got a solar panel, some batteries, an inverter, an air still, and you live by the ocean, you'll never run out of drinking water. Now, the water itself is nothing special, of course. It literally is just ocean water. I walked down into the beach early this morning. There is a little bit of footage of me grabbing the water. It's just a matter of scooping up a heap of water into the bucket. This here, you're looking at about 5 litres in there, I believe it is, probably a little bit more. Of that, I'll be using the 4 litres to put into the air still. So out of the box, this is what the air still looks like. Label there. It's obviously got a reset button there. It's also got the lid on the top here. It's all about copper coils. and actually drawing the water up, running it through the copper coils and condensing it, and from the condensation you'll get the feed from here. It's a matter of just switching it on here. A little bit more information in regards to model number and that there. Turn it on here, but it's just a matter of taking that lid off, like such. Remove it there. It's just a matter of peeling that lid off, like so. And that's exactly where we're going to want to put our 4 litres of water in. Now, one of the first things you're going to want to do once you've gotten your still set up is obviously give it a rinse out, make sure it's nice and clean and tidy. Same goes for the lid as well, make sure it's nice and tidy. And we don't want any contaminants going into the mix. The next thing we're going to want to do is go ahead and start measuring out the ocean water into the measuring jug itself. We're aiming for 4 litres in total. After that's done, we're going to want to pour it through this sieve. Now, the reason we're doing that is purely because I want to collect the salt at the end of it. If it was just for drinking water, it wouldn't be a necessity because all the solid matter would remain behind in the still after the distillation process has been completed. So as that's such, we're going to be using a smaller measuring jug to measure into the larger one. It doesn't matter about any of the contaminants on the top of this one. It's all about just removing it from one bucket into the next and getting our measurements correct. And the reason we want to stick with our 4 litre mark is purely because that is a 4 litre still. Now, another thing that's definitely worth mentioning is the fact that we want to be able to weigh this water purely for scientific purposes, just so we know exactly how much salt water we extracted, fresh water we extracted from the salt water, and also the amount of salt that's been extracted from the 4 litres of water as well. So we're just going to use this jug, we're going to measure that up, we'll just tear that off so that's flat lined. Now we're good to go. So we'll just measure out from this jug here, from that bucket into that jug. Now at this point here we have almost 2 litres of water, so we'll just get that to the 2 litre mark. And that there's to the 2 litre mark. As you can see, there is a little bit of particulate matter in there, but we'll be putting that through this paper towel here in this filter, this screen, and putting it into the still that way. That way all the particulate matter's out of it, and that way when we collect the salt at the end, it's as clean as possible. And now that we have our 2 litres, obviously we're going to be pretty precise with this. We just want to repeat that. It's a matter of transferring the water from this one over into this one. This will take a little bit of time for it to filter through. You can actually hear it there now, it's filtering through, so let it do its thing and it'll take all the particulate matter out of the seawater. Now, for the sake of sanity, I've decided to do away with the paper towel. It was simply taking too long and time is of the essence. So I'm just going to be able to transfer from one into the next, speed things up a little bit more. We'll still keep the screen on there, of course, that way if there's any particulates in there and they don't go through the screen, we'll be caught and we can remove it. It's actually very clean considering the ocean this morning was extremely rough, so I'm surprised at how clean the water actually is. Now again, as you can see, this is our second batch. We have the 2 litres of water, and with the 2 litres of water, we have precisely 2.019 kilograms of water. That's important because we know exactly that we've put 4 litres of water into the still, and at the same time, we have about 4 kilograms of water as well. Once we're done, we should be left with so many kilograms of water and so many grams of salt from the extraction process. It's just a matter of pouring the remainder in. This is the last of the water to go in. Pyrex isn't very pour friendly, which is a bit disappointing to be honest. If I pour too hard, it seems to run everywhere, so we want to concentrate on getting that correct. We want the same quantity in the still as what we've measured. Now we're going to go ahead here and just remove the strainers from the top. As you can see, the water is a little murky. It's not as clean as I'd hoped it would be. There is a little bit of particulate matter on the top of the water here, as you can see just there. I will do my best to remove all of that. Keep in mind, the actual water, the drinking water that we'll extract from this, will be as pure as you can get drinking water. The particulates and stuff like that will actually settle to the bottom of the still once the process is finished, and will remain with the salt. So the salt may be contaminated, but keep in mind, this is a process that people have been doing for thousands of years, and we've been eating particulates such as these organic particulates that's in this salt water for millennia. And it hasn't affected people in the past, and it shouldn't affect people in the future. The microplastics, on the other hand, they're something a little bit harder to extract from it, but that's the topic for another time. Now, the true beauty of the air still is its simplicity. So it's just a matter of putting the lid back on top. It doesn't screw on or anything like that. It's actually pressure sealed. So once the weight of it's actually pushing down on the device, it creates a seal here. It's just a matter of plugging that cable back into the outlet there, and then plugging the electrical supply in as well, and then turning it on. Once you turn it on, you'll feel the fans engage, and then the process will begin shortly after. This will take a few hours to do. I did think that I will be running a timer against as well, so by the end of this experiment, we'll know exactly how long it took, how much power it consumed, how much salt we extracted, and how much drinking water we extracted from it as well. Should be very interesting. Now, to collect the distilled water, I'll be using the same jug that I actually poured the water into the still with. All it is just a matter of actually going ahead and giving it a clean out, give it a rinse out. You don't want any salt in there. Dry the device, the vessel up, and then it's a matter of just sitting it underneath the nozzle here. And as the distillate appears from it, it'll actually drip out of the nozzle here and straight into the jug here. I'm hoping over a period of time that we get up to 3.5 to 4 litres from the device. But it will be very interesting to see exactly what the quantities are. This is not something I've done in the past. It's the first time I've ever done this, so I'm as excited to see what the results are as you are. Now we're 47 minutes in, or 48 minutes in. The vessel itself is starting to heat right up. So basically the way it works, it will boil the water off from the bottom, condensate it, and then it'll drip out the feed at the top here. It is taking a little longer than I thought to actually engage and start the process. All right, so now we're at 1 hour and 24 minutes into the actual experiment. About 1 hour 20 minutes in, it started to feed from the condenser. So now we're actually getting ourselves pure drinking water from ocean water. I haven't tasted it yet, but I look forward to doing so very shortly. In fact, what I'll probably do is I'll let it fully condense out, so it could take up to 3 to 4 hours, but we'll see how long it takes. Then we'll measure it after I've finished measuring the exact quantity that we've received from the condenser itself. Then I'll have a taste test. Okay, so we are nearly at 4 hours. We've collected 1 litre of water exactly. I've actually tipped a little bit back into this jug here at the moment. There's still a little bit left here. I've noticed that there is a little bit of a smell to the water. It's obviously because it's ocean water. It actually may have some of the fish oils in the water itself. So what I'm going to do is I'm going to complete the condensation of all 4 litres, or as close to it as I can get. Once that's done, I'll be doing a taste test. There's a good chance, because it's distillated water, that all the minerals have been extracted out of the water itself, and water such as this in large amounts is actually not good for the body. Apparently it's always a good idea, if we can, to actually perhaps mix a little bit of the seawater back through it. It wouldn't be a great deal. You'd be talking 10 mil, 15 mil, something like that, just to add some of the minerals back into the water. I do know one thing though, that there is enough water to get you out of some serious trouble if you're ever desperate for it. We've got 1 litre. I'm talking 1 litre of water. It's 5 cups of water almost, 4 cups, 5 cups. It'd certainly get you out of trouble. Pretty much this thing would have to run all day. In fact, if you had a large family or whatever, you'd need multiple running all day. Now, as I said, we're 4 hours into it and I'm about ready to go to bed, so I'm going to leave this. Obviously, now you're talking 1 litre in 4 hours, so it's going to be about 8 hours just to get this jug full. Talking 2 litres there, so literally 8 hours from now, which will be 8, 12, 4 o'clock in the morning, which is normally when I get up anyway. This jug, I would expect it to be full. I guess time will tell. We'll see you in the morning. So as you can see, it is 2:30 in the morning. And the 2 litre jug is over full. So it was a bit quicker than I thought, but we're talking an hour and a half earlier. But there it is. I'll empty that into that jug there and continue on. So I just come back out and I thought I'd check on this before I went back to bed. It's now about 5 to 3, so it's about 25 minutes after checking it after the 8-hour stretch. And as you can hear, the still has actually switched off completely. I gave it a shake there before just to, it feels like it's completely empty. And it looks like we may have extracted the final amount of water from the salt water itself. So I dare say that's the process completed actually, so I was lucky to catch the end of it. Otherwise I wouldn't have had an idea of exactly what time it finished. As I can figure, yeah, about 2:55 or 2:50 in the morning was its completion time. So what I'm going to do is leave it for the time being. They recommend not removing the lid for at least half an hour to an hour, just to let everything settle back down inside the still. And then once that's done, I can actually go ahead, remove the lid, and then I'll be able to collect the salt actually out of the still itself. So we'll have the salt and then we'll have the water that we've collected as well. Okay, after allowing the still to cool down, it is now time to remove the lid. Allowing it to cool has actually allowed the moisture inside of it to recondense back into the salt as well. I've left it for about 3 hours for it to cool down, which is probably a little bit too long because any moisture left in there will recondense. However, if you've got the opportunity, half an hour to an hour would be a good opportunity to take the top off, purely because any steam left in there will actually evaporate out of the still and not back into the salt. So it's a good opportunity to get rid of that moisture before it recondensates back into the salt. Now I haven't had a look in here yet, so we're all doing this together. Move this off here. I'm expecting there to be salt in there, hopefully. Yes, there is. And that's what we're left with there at the moment. You can see it up the sides there, it's all crystallized. There is quite a bit there, and it is still quite a bit of moisture in there as well, which I was expecting. If I'd removed it earlier, there wouldn't have been as much moisture in there. There is a way to remove that, and it's very simple, and I'll show you how to do that shortly. All right, now I've removed the majority of the salt from the still. There is still a bit of moisture in there, there's still a bit of salt as well. But what I'm going to do is I'm going to allow the still to remain open, and allowing it to remain open will allow the remainder of the moisture to escape, which will make collecting the remainder of the salt that's in there very easy. It should dry, it should be crumbly, you should be able to wipe down the walls and the bottom and then scoop it out with a spoon. Once that's done, I'll add it to the majority of the salt that I've removed, and we can apply some heat to it, remove the moisture from it, and then we can weigh it. Now this is the majority of the salt that I removed. I've actually put it into a frying pan, and we're just going to apply some heat to it, and we're going to remove the remainder of the moisture from it. Once this is done, we can go ahead, put it on the scales, weigh it up, see exactly how many grams of salt we got compared to how many litres of water we actually got as well. This is what it's all about, basically coming down, doing the final measurements, seeing exactly how many grams of salt we've received and how many litres of fresh drinking water received from the 4 litres of salt water that we put into the still to begin with. There are of course better ways to do this. You could continue to clean the salt, however cleaning the salt requires you to use more water. I didn't want to have to use any of the water I've collected at this stage. I wanted to do it as straight as possible, so I just applied the salt as it was from the still directly into the frying pan. So if there's any sediment remaining or any grains of sand, they will actually be in here as well. However, this is about as traditional as it gets when it comes to collecting salt. Traditionally though, they used to actually dig beds by the seashore, and they'd run the seawater into the beds, and then they'd block them off and they'd allow the sun to evaporate all the water out of it. Salt's always been a very valuable commodity throughout history. Heating the salt in this fashion as well, compared to allowing it to evaporate in the sun, will actually kill any of the bacteria that may remain in the water. So if there's any moisture left in the salt and there's any bacteria in that moisture, applying the heat to it will definitely kill it. So it's actually a very sanitary way of preparing the salt for the kitchen table. Now, to some people, looking at it and you go, it's just salt. There's nothing very special about it. To me, on the other hand, it's amazing. Like, I don't just see the salt that's been removed. It's also the magnesium, it's the calcium, it's obviously the sodium chloride. Like, there are positions around the world where they actually harvest the seawater and they remove the magnesium from it, for example, and they put it into tablet form, and that's how you get your magnesium in your breads and also in your dietary supplements and stuff like that as well, is exactly through this process. So obviously there's a bit more to it. At the moment, all of the minerals are together. So you're talking calcium, sodium, magnesium, they're all combined together in this one pot. It is possible through extraction processes to refine this even further. So you can remove the salt from it, the magnesium from it, the calcium from it, through different procedures. It's a little in depth, it's not something I've done in the past, but it is possible, and that's how you'll find a lot of pharmaceutical companies actually get their vitamins. Alright, so I've had a chance to weigh up the salt. We've got 141 grams approximately, so 140 grams of salt removed from the 4 litres of water that we distilled. I'm yet to measure this jug here, but we'll do that next. Okay, so now it's time to measure up this water finally. This is what it's all been about, is how much drinking water we can actually get from it. So we'll tip it into the jug, back to where it come from. Should be about 3.5 litres, which means we did lose a little bit. It is understandable. I did get to it a little bit late. It was around 2:30 when I did get to check it. I perhaps should have got to it at 2 o'clock. I would have saved a little bit of waste going on the ground, but you can't win them all, unfortunately. The main thing is we got the majority of it, and it will give us a very good indication of how much drinking water we can actually get from it. So at this point here, that's 2 litre mark. Yep. Okay, and now for the remainder of it, measure it up. As you can see there, we get another 1.5 litres out of it, which would indicate 3.5 litres of water removed, 140 grams of salt, and you're talking maybe 350 grams loss that I spilt this morning, very early this morning, about 2:30. Okay, so just to reiterate, go back over everything that we've gone through this morning already. We have 3.5 litres of distilled water from the 4 litres of ocean water that we distilled, and we have 140 grams of salt. It's actually gone up to 143, 144. It's alternating between those two, but rest assured, we know for a fact that we got at least 140 grams of salt. There is still some salt remaining in the still itself and a little bit in the saucepan that I used to heat it back up with. So I'd reckon 150 grams maybe, just to square things off. It's a good idea to be as precise as possible. I'd prefer to actually account for the salt that's in the saucepan and that's in the still. And as that's the case, there definitely would be more than 140 grams there. What I'm going to do next is I'm going to work out the value of the salt commercially today, if you were to go and buy table salt from the shop. And I'm going to work out the value of the distilled water as well. Now, distilled water is not as cheap as regular tap water, but we can work it out. We'll go find out the price of its worth as distilled water. We'll find out its worth as tap water, and we'll also find out its worth as bottled water as well. And that will give us three perspectives to see exactly how much the value of the water is that we actually have. Give us a very good overview of it all.